In this video, we're going to have a look at probability at National 5 numeracy level. We'll build this up to the standard that you could expect to see. There are 4 yellow, 3 red, 1 blue and 4 orange cubes in a bag. Jason takes a cube from the bag. What is the probability that it is orange? So you want to figure out the probability that it's orange. So we'll say the probability that it's orange. So we'll take the number of ones that are orange. So there's 4 orange. And we'll divide that by the number of cubes in the bag altogether. So there's 2 plus 3, which is 5, plus 1, which is 6, plus 4, which is 10. So altogether, there are 10 cubes in the bag. 4 of them are orange. 4 divided by 10 is 0.4. That's the probability of picking an orange cube. The cube is replaced in the bag and 3 white cubes are added to the bag. So I'm just going to write this down. So we've got 2 yellow, 3 red, 1 blue, 4 orange, and now we've got 3 white. What is the probability that the next cube taken from the bag is not red? So the probability that it's not red. So we need to figure out how many are not red and divide that by the total. So once again, the total is going to be 5, 6, 10. The total is 13. The total that are not red is going to be 3, 7, 10. The probability of not choosing a red one is 10 over 13. 10 over 13 is 0.77 or 77% chance. Okay, part B. Question 2 really. There are 4 girls and 14 boys in a class. A child is chosen at random and is asked to roll a dice numbered 1 to 6. Which of these is more likely? A, a child is female, or B, the child rolls a 4. Justify your answer. So we need to figure out the probability of choosing a female. So the probability of choosing a female, how many females are there? There's 4. How many in the class altogether? 18. So the probability of being a female in that class is 0.222. Now if we have a look at the dice roll, we want to figure out the probability of rolling a 4. So there's 6 outcomes altogether and there's 1 4. So the probability of rolling a 4 is 1/6. And 1/6 is 0.166. So which of these is more likely? We need to compare these decimals, and this decimal is clearly bigger than this decimal. We need to make sure we've got the same number of decimal places. So we'll just say it is more likely to be a female, or to choose a, more likely to choose a female than to roll a 4, since 0.222 is greater than 0.166. Once again, you need to relate it to the question, then have a numerical comparison at the end. Okay, example 3. 50 people took part in a health promotion campaign. They were asked whether or not they smoked cigarettes. The following table summarises the responses. So we need to make sure, is there actually 50 people? So 3 plus 21 plus 8 plus 18, yeah, 50 people. So there were 3 male smokers, 8 female smokers, 21 male non-smokers, 18 female non-smokers. What is the male that a person chosen chosen at random from this group is male? Okay, so we want to figure out the probability of being a male. So there's 50 altogether. So how many males are there? Well, there's 24 males. So 24 out of 50 is 0.48. Part B, what's the probability of being a smoker? So once again, it's out of 50 altogether. How many smokers are there? Well, there's 11. And 11 divided by 50 is 0.22. Finally, part C. I'm going to do this up here. Part C. Probability of being a female who smokes. I'll just say a female smoker. So we're going to the female smokers. So here we are here. That's going to be 8 out of 50, which is 0.16. Question 4. Local council has compiled the following information about 500 properties and their owners. Okay, so we've got different categories here. So there's 500 properties altogether. What is the probability that a house chosen at random is owned by someone over 50 years old? So that's this column here. So say the probability of it being owned by someone over 50. So we said there's 500 properties altogether. We need to figure out how many properties are owned by over 50s. So we're going to need to add those values together. 168 plus 66 plus 41, which is 275. And that is going to give us 0.55. The probability is 55%. Part B. There are 2,500 properties in a housing estate. How many would you expect to be both semi-detached and owned by someone over 50? So we're looking at semi-detached and owned by someone over 50. So semi-detached and owned by someone over 50. So we need to first figure out what is the probability of owning a semi-detached when you're over 50. We'll just put semi-detached over 50. So once again, there are 500 properties altogether, and 66 of them are owned by over 50s, and that are semi-detached. So that is a 0.132 probability. Okay, so if you think about this in terms of like heads or tails with coins, the probability of rolling a heads would be 0.5. And if you were to do this 1,000 times, you'd expect to get 500 heads. You wouldn't get it, but you'd expect it. So what we're going to need to do now is we're going to take our probability, what we expect, and multiply that by the number of properties that there actually are. So there's 2,500 properties. So we're going to need to multiply that by what we expect. So 2,500 multiplied by 0.132. So we would expect 330 properties to be owned by someone over 50 that are also semi-detached. Okay, final example. A retailer orders tins of soup in boxes of 80. The probability of a box containing at least one bashed tin is 0.012. The retailer finds that a delivery of 10 boxes of soup, 12 tins contained at least one bash. Is this more or less than expected? Okay, so let's have a look at what they ordered. One box has 80 tins. They ordered 10 boxes. So they ordered 10 boxes. So that's going to be 10 lots of 80 tins. So they had 800 tins altogether. The probability of having one bashed, or having at least one bashed, is 0.12. So of their 800 tins, we can calculate how many we expected to be bashed. So we're doing 800 multiplied by 0.012. So we would expect 9.6 tins to be bashed. Whatever that means. Maybe 9 or 10. So the retailer actually found that 12 tins were bashed. Is this more or less than expected? Well, we would expect 9.5 tins to be bashed, but we've got 12 tins, so this is more than expected. We'll say more tins were bashed than expected. And we'll just say since 12 is bigger than 9.6. So we've answered the question, and then we've got our numerical comparison. Okay, so that's a wee overview of probability at National 5 numeracy level. Thank you very much.